And if you wind up then going on less than what you need to go more than 7 times a month for it to be worthwhile, and if you don't, and you wind up paying $17 per visit, then in some sense, it seems not unreasonable to think that maybe you've made a mistake, right? So, for example, if you were a naive hyperbolic discounter, then we could explain these findings, right? When both the cost of exercise, which I think, I don't know about you, but I find going to the gym somewhat aversive. So there's a sort of psychic effort cost, blah, 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 it's time, I have to sweat, blah, blah, blah. When that's in the future, and also the long-term health benefits are in the future, when I'm deciding whether or not to buy the monthly membership contract, I'm not discounting those two things relative to one another because they're both inside data, right? They're both in the future. Okay, so I think to myself, yeah, of course I want to go to the gym. I want those health benefits. It's not that bad to go to the gym. The health benefits far outweigh the psychic effort cost of having to sweat in public. So I want to go to the gym a lot. And to make that cheaper, I'm going to buy this contract. It's a great deal. Right? And then when the time comes to exercise, what happens is that the cost becomes immediate. So it steps outside of theta. And so all of a sudden it swells up in your mind and you think, still like the idea of not dying of a heart attack when I'm 52, but I don't want to get out of bed right now. Okay? So that's pretty straightforward. And I think most people would sort of guess that that's what's going on. Palace. Oh, did they look at the reverse? The people who paid per visit and then actually went a ton of times and should have had the contract. I'm guessing they didn't, and I'm guessing the reason they didn't is because this model wouldn't really have much to say about those people. So if you expect to not go very much and you don't go, if you expect to not go very much and then you do go a lot, I'm not sure how we would explain that with discounting, because what that seems to suggest is that you thought you wouldn't get out of bed, but then when you got there, you turned out you weren't actually discounting that, you weren't impatient, you thought you were more impatient than you actually were, which is kind of the reverse of what our model predicts. Now, what I would look at in that case is a model of habit formation, and maybe what you didn't realize is that once you start going to the gym a little bit, you're going to start to like it, which is in fact a process that I'm exactly in the middle of, right, this semester, is going to the gym and discovering, oh, it's kind of fun. People don't actually look at you as often as you think that they do. Other people don't care that you're there sweating. It's not as bad as you thought. And if you mispredict that habit formation process, that would explain your results, right? So we'll talk about that next week. Yeah. Okay. But it turns out that these observations of people buying these contracts and then not going to the gym enough times to make it seem worthwhile are actually also consistent with a model of sophisticated hyperbolic discounting in a way that may surprise you a little bit. Okay? So here's the story, and here's the intuition. Sophisticates have exactly the same preferences as naive. So they too, from the perspective of deciding whether or not to buy the contract, would like to go to the gym a lot. Right? Same person, same preferences, same preferred plan. They realize that they won't if they have to pay $10 every time. It's like, oh, now it's not just the cost of having to get up in the morning. I also have to plonk down $10 every time. I'm not going to do that. But if I get a monthly membership contract, then the immediate cost of going to the gym each time goes down because I don't have to pay the price every time. I just have to overcome the effort cost. And if they're in the range where the cost of just having to get up in the morning is not overwhelming, but the cost of having to get up in the morning and pay $10 every time is too much, then buying the contract it's not a commitment device, but it's something like that. It's a way of giving your future self a nudge. Okay? It's almost like paying someone to come and make coffee for you before you get out of bed, to reduce the psychic effort cost of getting out of bed and going to the gym in the morning. So they're willing to pay a premium, right, the $70. They're willing to pay a $7 per visit premium to just get that little helping hand to get them out of bed in the morning, and because they don't have to pay the immediate price. Now, I'm just curious before I go into the model, how compelling is that to people? Raise your hand if you think, oh yeah, I can totally see that. Okay, let me ask those of you who just raise your hand. If you go to the gym on a pay per visit basis, when do you actually experience the disutility of the daily payment? So Diana says before you go. Anybody else? When your credit card is due, if you paid for it on your credit card? What were you going to spend that $10 on? Some other consumption. When were you going to engage in that consumption? Presumably not right when you were going to go to the gym. Presumably you're not actually getting up, say, for example, breakfast. Right? Maybe you go to breakfast and you eat out of Bongo Burger and it costs $10. And it's like, well, if I go to the gym and have to pay that $10, I'm not going to be able to go to Bongo Burger. So that means I get to exercise, but I'll be hungry. That's all immediate. That's just not how it works. The $10, you swipe your card to the gym and they charge you $10. I'm not convinced that you experience that as immediate. Okay? So this is a question that will come up later of what's immediate and what's not. Hopefully. Nonetheless, let's look at the model and then we're going to test it. So here's a simple model. I hope simple. 3 time periods, 1, 2, 3. In period 0, this is you've seen this, I think, by now. You saw it in the problem set. Period 0 is just a decision period. There's no actual consumption going on. There's no going to the gym or not going to the gym. You're just deciding whether or not to buy a membership based on what you think you'll do in the future. Period 1 is you decide whether or not to go to the gym. Now, in reality, there's multiple period 1s, right? Because there's every day you get to decide whether or not to go to the gym. But I'm just keeping this as simple as possible. And then period 2 is when you're 52 and have a heart attack, or don't. Okay? So we'll just go with that. Let's just keep it really simple. Then here's your utility. There's an immediate effort cost of going to the gym, which is C, okay? Because it's just a pain. There's some long-term health benefit, which is B, which might be greater or less than C. Then there's a per visit price, which is P if you don't have the contract, and 0 if you do. All right? And there's the fee for the contract, which is F. So the two questions we want to answer are, when would a sophisticate want the contract, and then how much would they pay for it? Okay? All right, here is a table of instantaneous utilities. And again, just in terms of helping you to think about how to solve problems, the thing I want to draw your attention to is that the columns, right, the rows are still in terms of time periods, and what perspective you're looking at. Is it the undiscounted long-term perspective, the time 0, only the immediate present is discounted, or T1, I've moved forward period, and the immediate, in time 0, only the immediate present is undiscounted, in time 1, I move forward period, and only the immediate present is undiscounted. The columns are no longer defined by time periods at all. Okay? As before, what they're defined by is what action you choose. Okay? So what we want to know is, what are the payoffs, short and long term, discounted or undiscounted, from different choices that you might make from different perspectives in time. Okay, so we've normalized the utility of not going to the gym as 0, so we don't have to worry about discounting. If you don't go to the gym, it doesn't matter whether you have a contract or not, you're not going to get any utility. We can just normalize that to 0. If you go to the gym without a contract, so you have to pay P every time, what you get, so this is just the undiscounted utilities, you get B in some future period, because you don't have to die of a heart attack, but you then have to give up, in the immediate period, C and P, the financial cost and the effort cost. And the instantaneous just means, what are these numbers if we don't discount them? It doesn't matter when in time they come. Whereas without a contract, it's just B minus C, because you don't have to pay that price. Okay? From the perspective of time 0, when you're deciding whether or not to purchase a contract, what do we have? Well, the health benefit is in the future, so you're going to discount that. It's way out in the future. effort cost and the price of going to the gym are also in the future. They're much closer, but they're still in the future, so they are quote-unquote inside beta. So you're going to discount both of those things, which interestingly, keep in mind, means that when you're deciding whether or not to go to the gym, since they're both discounted, you weigh them equally. So you're going to make a sort of reasonable choice if you foresee that you will discount them. Meanwhile, if you go to the gym without a contract, it's just the same thing without P. Then from period time equals 1, from period 1, when you're actually deciding whether or not to go to the gym, you're still discounting the future health benefit, but you're no longer discounting the effort cost of going to the gym or the price of having to go to the gym and pay for it immediately. So we're just assuming that you do really feel that price immediately. And again, with a contract, it's the same thing, but without P. Okay, now then. We have to go through a few more steps than we have in stuff examples we've worked through before, up till now. So let's just think about, without a contract, what would this person's period 0 self prefer? Okay, without a contract, from the standpoint of this is the point where you're deciding whether or not to contract. Yeah. Because I want to introduce that later when I figured out all the other dimensions of value for the contract, and then I'm going to stack that against the fee. Yeah, I'm going to do that in the next slide. Sorry? Bingo. So one Jiku's question was, why is beta the same for all ages? Why is it that, I mean, you hope that as people get older, they learn some of these, they become more patient. We're just waving our hands at that. Yeah. Let's just say it's a heart attack 3 weeks from now. Okay. So the first thing we want to do is to figure out when would she want the contract. So that we have to figure out what utility will she get, or what utility will her period 0 self get out of having a contract? What utility will her period 0 get out of not having a contract? Right? This is utility maximization. This is the most basic fundamental building block of microeconomics. You get a choice. What's the utility you get out of each choice? Which one's bigger? That's your choice. Okay. So without a contract, now we have to figure out what she'll actually do. Okay. First of all, what would her period 0 self like to do? Well, from the perspective of t equals 0, she wants to go to the gym if going to the gym without a contract, this thing, is bigger than not going to the gym. Okay? So if beta b minus beta times c plus p is greater than or equal to 0. Okay? Now we can get rid of those betas, right? I told you that when everything's in the future, beta doesn't matter because it's not causing you to disproportionately overweight the earlier outcome. So if that is true, it's the same as saying that b is greater than c plus p. Well, that makes sense. From the sane and sober standpoint of the future of the earlier period, she says, you know what I'd really like to do is to go to the gym if the long-term benefit outweighs the short-term cost, with no discounting taken into account. That's what it means. That's what it means to sort of think to weigh future outcomes that you're not discounting relative to one another. We could rewrite that as if the price is less than the net benefit, right? B minus C is the net benefit, and if the price that you charge me doesn't swamp the net benefit, then I'll go and I'll pay the price. Fine. Okay, so I might say, no, I don't want to say that yet. Sorry. So from now on, let's just assume that's true. Let's just assume that this is someone for whom the long-term benefit of going to the gym does in fact outweigh the short-term cost. Okay? So they would like to go. Then what will her period 1 self actually do? And that will determine whether or not, that will help us to begin to think about whether or not she wants the contract. So from the perspective of t equals 1, right now she's looking forward. So this is backwards induction. She's looking forward to think about what her period 1 self will actually do. Her period 1 self won't go if, so that's period 1. I know that I won't go without the contract if this number is smaller than 0. If beta b minus c plus p is less than or equal to 0. Okay, which implies, or rather that condition can be rewritten as if beta b is less than c plus p. Okay, so it's the same basic thing as this, but it's like, okay, I want to go because the actual long-term benefit is greater than the short-term cost, but I know that when I'm discounting that future benefit but not discounting the immediate cost, that benefit won't feel big enough anymore. Okay, so I won't go, which is another way of saying if p is greater than or equal to beta b minus c. So there's this range where the price is low enough that she would like to go to the gym without a contract, but high enough to prevent her from going to the gym without a contract. Okay, so let me show you that. So if the price p is greater than beta b minus c, right? So it's enough to keep her from going to the gym at time 1, but it's less than b minus c. So it's not enough to make her not want to go. She'd like to go, but she doesn't go. If p is in that range, okay, then she's someone who without a contract wishes she could go, but she won't. Whoops, sorry. She won't, and she knows she won't. Now, with a contract, right? So we're doing utility maximization. We need to know what are the outcomes in both cases. With the contract, her period 0 self will still prefer to grow. The contract only makes it more desirable to go. Okay, so with the contract, her period 0 self will want to go if beta b minus beta c is greater than 0. Okay, and we can just get rid of the betas and say if b is greater than c, she'll want to go because now she doesn't have to worry about the price. So if b is greater than or equal to c plus, if b is greater than or equal to c plus p, then it's certainly greater than c. Right? So we already said, yeah, let's just assume that it's the case that she would like to go even with the price. So obviously if we take the price away, she still wants to go. She still would prefer to go. Okay. But now what will her period 1 self actually do under the contract? So looking forward to period 1, with the contract she'll go if beta b minus c is greater than 0. So from t equals 1, she will go if the utility of going with the contract, beta b minus c, is greater than or equal to 0, which is the same as saying if beta b is greater than or equal to c. Okay? So before, we needed to consider whether beta b was greater than or less than c plus p. Now it only needs to be bigger than c. And so what that means is that there's this range. If beta b, so beta b is she wakes up in the morning and she's thinking about whether or not to go to the gym, and she's thinking to herself, it sucks to go to the gym, and I'm not discounting that. I know it's going to be good because I won't have a heart attack in 3 weeks, but I'm discounting that because it's still in the future. That's beta b, is her discounted future benefit of going to the gym. If that number is big enough to get her out the door, it's greater than c, So it's big enough to get her out the door without the contract, but it's not big enough to get her out the door without the contract where she has to pay P. Right? So if she's right in this range where having the contract would lower the immediate cost of going to the gym just enough that she would actually do it, okay, then she wants the contract. Does that make sense? So let's just assume that that's true. So let's assume that this is someone for whom going to the gym is a good idea in the long run. Right? That's what we assumed here. And someone for whom getting the contract and not having to pay P would be enough of an incentive to get her out the door and actually make her go. Okay? And by the way, suppose the guy said something stupid about what if the contract was for someone to come and make her coffee, but that's in fact exactly what a lot of sophisticates do, right? They say, let me get a gym partner. Okay? So now I know that it's actually there's going to be some social utility of going to the gym, or I'm going to disappoint them if I don't show up, or maybe your gym partner actually brings you a cup of coffee. So now how much will she pay for the contract? So do you understand now why I didn't include the fee earlier? Okay. From the perspective of time zero, without the contract, she won't go to the gym. We assumed that. We're looking at a particular case where without the contract, she won't go to the gym, so she'll get zero utility. With the contract, she will go to the gym, and she'll get the net benefit of going to the gym, B minus C, but she's discounting it because it's all out in the future. Okay? So she gets beta times B minus C. So she'll buy the contract if the fee is less than that. Right? The commitment device, what is this beta times B minus C? This is the net long-term health benefit that she knows she will fail to get for herself. This is the cost of naivete. This is the long-term health cost of her, and I'm sorry, not naivete. This is the long-term health cost of her impatience. And because she foresees her impatience, this is a consequence of impatience that she predicts. This is the value of the consequence of her impatience, which she predicts. So if she can sign a contract with someone that will prevent her future self from detonating her long-term health outcomes to this extent, she will be willing to pay up to that amount for that contract. Okay, well that's all very well and good. So this shows us, this is just a model. We sort of like to do these models where, okay, you have an empirical paper and you found a bunch of stuff and you think it's really interesting and you theorize that it could be explained by some model. You have to sit down and actually show that it could be explained by that model. We've just done that in a super, super simplified situation. Delving in on one day doing it with a much more complicated version of the model. Okay, that's a nice exercise. It proves nothing. What if we want to actually know? Because it matters for public policy whether people are naive or sophisticated gym goers. Okay, so in the paper what they do is they say, it also turns out that these people who've signed up for a monthly contract and aren't going enough to make it worthwhile, when they stop going completely, they then wait like 2.5 months, almost 2.5 months on average, before canceling the contract. Which means that it winds up costing them $187 in contract fees during a time when they're not going at all. Okay? Now, they estimate that the transaction cost for taking the necessary steps to cancel is about $15 in time cost, right, for the median employee or whatever, at the median wage. So if someone's, what does this look like? What kind of behavior, what do we call this kind of behavior? This is procrastination, okay? So then we want to know, is it realistic to think that a sophisticate would procrastinate this much? And it turns out that you can use the beta delta model. If you have an estimate of this transaction cost, and if you have an estimate of B, the long-term benefit of going to the gym, you can sort of back out what range of procrastination it would be realistic for a sophisticate to do and what range of procrastination you'd have to be naive to do. Right? Because we know that the naive does more procrastination than the sophisticate. And they've cranked these numbers and they've concluded that it's really not realistic. This degree of costly delay can only be explained by naivete in the model. Okay? Which makes sense to me. But it's not clear that that rises to the level of scientific proof. What would we do to determine for certain whether gym goers are naive or sophisticated? Well, not surprisingly, my answer to the question is conduct a field experiment. Okay. Shameless self-promotion, round one. This is me and a co-author named Matt Levy, who graduated from here a few years ago and is now at the London School of Economics. I say 2011 and counting because we are procrastinating on getting this paper published. I actually had a conversation just this morning with Matt in which I said, we're starting to look silly. We should get this published. Okay, here's what we did. This is actually a small part of what we did. I'll come back to this when we talk about habit formation and projection bias next week. Among other things, what we did, we took a bunch of people, Berkeley undergrads, and we paid them to go to the gym, and we looked at a bunch of habit formation stuff. But along the way, we got people to predict how often they would go to the gym in some future week, a target week that we'd specified. Okay, how do we do that? We offered these subjects a coupon that would pay off with some face value amount, $1, $2, I think we had 1, 2, 3, and 5, and 7, per visit. So you could go once per day during the week, so you could make up to 7 times P off of this coupon during the target week if you actually went to the gym. Okay? And then we asked people first, we asked them what was their willingness to pay for a coupon like that. We use this, we use the Becker Group Marshak thing that you've seen before. And we asked them how much they'd be willing to pay for a coupon. Well, if you're willing to pay a maximum of, let's say, $10 for a coupon that pays off $5 every time you go to the gym, it suggests you think that you're going to go to the gym about 2 times that week, right? Because if you thought you were going to go to the gym more than that, you should be willing to pay more than that for the coupon. And if you thought, well, I'm actually out of town that week, which came up a couple times, then you wouldn't be willing to pay anything for that coupon, right? Okay. So we claim this is an incentivized elicitation of their predicted future attendance. We then asked them, suppose that you had been given this coupon. How many times do you think you would actually go to the gym in response, under those conditions? And so we think of this as an unincentivized elicitation of their predicted future attendance. Right? So we have two different. If you like the incentive mechanism we've used, great. If you don't, we have an unincentivized version instead. They turn out to be very, very similar. And then we actually gave them the coupon. We surprised them and said, all right, now that we've asked you all these questions, here's the actual coupon. And now let's go see how often you actually go to